This classwork begins with us solving equations for y. Really, this is a skill that's going to build towards us putting things in a proper y equals mx plus b form. So even though mathematically I could have the numbers come first and the x's come second, I want to get used to getting the y alone on the left-hand side and on the right-hand side of the equation listing the x's first and the numbers without a variable second. So for right now, when I look at number 1, I have y plus x equals 5. In this case, y is on the left where we want it, the number's on the right where we want it. The only thing that's out of place is this x. On the left-hand side, it's a positive x, so to move it, I have to do something equal and opposite, which means I need to subtract x. When I do that, equal and opposite means these go away, but because I subtracted x from the left, I have to subtract x from the right. When I say left and right, I mean of this equal sign. So subtracted x here, also have to subtract x here. On the left-hand side, it leaves just y. On the right-hand side, if I wrote this as 4 or 4x, that would be incorrect, because that would be me trying to combine two terms that are not like terms. I cannot combine negative x and 5 because they're not the same. For that reason, I have to leave it as either 5 minus x or negative x plus 5. The reason I'm choosing negative x plus 5 is because that's the format we'll need to be putting things in order to get it into y equals mx plus b form. So again, even though 5 minus x is mathematically correct, what we're doing is we're trying to put it into y equals mx plus b form, which means we have the single y on the left-hand side, we have the equal sign, then whatever's being multiplied by x, in this case really it's a negative 1, then added or subtracted whatever number has no x's with it. Second equation is certainly much more complicated. It has multiple steps we have to follow to do this. So the first thing, again, this x is out of place, specifically this 9x, equal and opposite. It's a positive 9x now, so I'm going to subtract 9x from each side. That's going to make these go away, and on the left-hand side, we're left with negative y over 3. On the right-hand side, I'm going to write it as x's first, then numbers, so I get negative 9x plus 3. I don't have y by itself. To get y by itself, I need to get rid of this 3 and this negative sign. It's currently being divided by 3, so to undo that divided by 3, we're going to multiply by 3. We're going to do that to each term on the right-hand side as well. So the reason we're multiplying by 3 is because we divided by 3 here. If you wanted to multiply by a negative 3, that would be perfectly fine in this step. I'm just doing it in 2 steps. So 3 times negative y over 3 leaves me with negative y. 3 times negative 9 gives me negative 27x. 3 times 3 gives me 9. Last thing I need to do to solve for y is to get rid of this negative. Really, to do that, what I'm doing is I'm multiplying the entire equation by negative 1. You could also see it as dividing by negative 1. In either case, what it really does is changes every sign in the problem. Negative times a negative gives me a positive, so now I have y alone on the left, which was my original goal. Continuing on, negative 1 times a negative 27 gives me a positive 27x. Negative 1 times a positive 9 gives me a negative 9. So my final equation is y equals 27x minus 9. Problem 3, they asked me to find 3 solutions and draw the graph for y equals negative x plus 4. If that's hard to see, it's y equals negative x plus 4. They give me what points I want to plug in, but these are exactly what I would choose. These are the easiest numbers to plug in and solve for. And then it asked me to graph it on this axis. So first thing I'm going to do is plug in the x values. I'm going to put in negative 1 everywhere where I see an x. So it becomes y equals this negative still stays there. I'm going to replace the x with parentheses, negative 1, and then plus 4. Negative times a negative gives me a positive 1. 1 plus 4 gives me an answer of 5. So I'm going to put 5 as the y value when x equals negative 1. We're now going to try plugging in the next x value. Y equals negative 0 plus 4. Negative or positive, 0 is 0. So that just drops out and I'm left with y equals 4. So when I put in 0 for x, I got 4 for y. Finally, when I put in a positive 1, I get negative parentheses positive 1 plus 4. That gives me negative 1 plus 4, which gives me y equals 3. put that here, and I now have 3 points that I can graph on my coordinate axis. The first point, -1, 5, tells me I go to the left 1 to move -1 in the x direction, and I go up 5, 1, 2, 3, 4, 5 to put a point there. Next thing that I need to do is 0, 4. 0 means I don't move left or right at all. I'm on the axis. I go up 4. It's about there. Next one tells me to go 1, 3. I go to the right 1, up 1, 2, 3. This line should look something like this. I always say when I'm drawing these by hand, obviously it's very easy to make a mistake, not have everything line up exactly right. For the most part, this is the general form of the graph that you get from y equals -x plus 4, and we were able to get it by finding 3 points through substitution. Second half of this classwork has us graphing using the intercept method. What the intercept method says to do is to plug in 0 for x to find what the y-intercept is, plug in 0 for y to find what the x-intercept is. So we're going to do that, which is going to give us 2 points. When we plug in 0 for x, we get 3y minus 2 times 0 equals 6. 2 times 0 is just 0, so this term disappears, and we're left with 3y equals 6. We can then divide 3 on both sides and get an answer of y equals 2. That tells me when I put 0 in for x, I get back 2 for y. Next thing we're going to do is plug in 0 for y and see what we get back for x. So 3 times 0 minus 2x equals 6. This term is 0 and goes away, so I'm left with -2x equals 6. If I first divide by 2, that would give me -x equals 3. If I then multiply by -1, that changes each of the signs and gives me x equals -3. What that tells me is that when I put in a y coordinate of 0, I got an x coordinate of -3. So, the intercept method, the goal is plug in 0 for one of the variables, solve for the other one. Switch it, plug in 0 for the other variable, and solve for the remaining variable. Hopefully it gives you 2 distinct points that you can put on a graph and connect into a line. The first point we found was 0, 2. That's 0 left and right, up 2. The second point we found was -3, 0. That's 1, 2, 3 to the left, up 0. If I take these points and I draw a line through them, that would be what my line should look like. So that's the process by the intercept method. For problem number 5, these are lines that you do have to be familiar with. Basically, they're horizontal and vertical lines. It can be confusing which is which. What I recommend you do is you hold whichever coordinate they give you static and then put 0, 1, and 2 in for the other coordinate. So this tells me y equals -2. Whenever I have an ordered pair, it's x comma y. So what I'm going to do is make 3 ordered pairs where I hold y to be what it must be for this equation. Y must be -2 because that's what the equation told me. I'm going to put in for x 0, 1, and 2. I now have 3 points I can graph. First graph, 0, -2. I go left or right 0, down 2. Second, 1, -2. I go right 1, down 2. Third, 2, -2. I go right 2, down 2. This is my line. You absolutely do not need to create these points. If you know y equals lines are horizontal at whatever the y value is, jump right to it and show me the line. That's perfectly fine. But if you're confused, you want to get it straight, but you remember x, y goes in this order, fix whichever one it is that should be fixed. Keep that in that set spot no matter what you change the other variable to be, and then just put 0, 1, 2 in for the other variable. If you graph it, it will give you the correct line. I'm going to use that same strategy for x equals 3. I'm going to make 3 points. This time, instead of fixing the second coordinate, the y coordinate, I'm going to fix the first coordinate, the x coordinate. So this is going to be 3 each of these times. I'm then going to choose for the y, 0, 1, 2. 3, 0 is there. 3, 1 is there. 3, 2 is there. So this is a straight up and down vertical line at x equals 3. Again, you do not need to create these points unless it specifically says in the instructions find ordered pairs that would satisfy this equation. As long as all it says is to graph the equation, you can jump right to a vertical line or a horizontal line, or you can use this trick of setting either the x or y static and not changing, and then just putting 0, 1, and 2 for the other.